Welcome to 204B, objective number 5. We're now going to look at what goes into the construction of the actual contacts inside your relay and why we would choose different materials to do different jobs. There's a number of different ways that contacts can fail within a relay, and I need to be aware of them in order to avoid that. And it's going to be my requirements that will determine what kind of material my contacts are made from. We're going to review some of the pros and cons of different types of metals that we have within our contact materials, and we will review the three most common types. We're going to start with silver. One of the best things about silver, it is a very conductive metal. In fact, if we look at our conductive scale, it is actually right on the very top. The other nice thing about silver is that as those contacts open and close, they tend to be self-cleaning, so they're going to get rid of any oxidization that occurs on those surfaces. Some of my cons are that the silver is a very soft metal, so therefore it's unable to handle high current or voltage. What will happen with a high current or high voltage is it will create enough heat inside those contacts that it will actually weld the faces of the contacts together. Silver contacts are typically found in smaller, low-power relays for small jobs. Our next material choice is copper. Copper is also a very highly conductive metal, and it is significantly harder than silver, which makes it much better suited for higher voltage and amperage applications, such as lighting or motors. However, since it is prone to pitting and oxidization, we could see an increase in resistance on the surface of the contacts themselves, so they're not really suitable for frequent switching. I'd want to use copper on any type of relay that I'm simply going to turn it on and off once per day. The last type of material I can typically see inside my contacts is cadmium. Some of the pros I have with cadmium, it is a nice hard metal similar to what copper is, and it is better suited for the higher voltage and amperage applications, and it is able to handle frequent switching since it doesn't pit or oxidize like copper does, and it is a very durable material. However, cadmium has a very low conductivity, so it has an inherently high resistance inside it, so it can generate extra heat. Even though these are the three most common types of materials that we find inside our relay contacts, most manufacturers will use an alloy that combines these materials together in order to improve their performance. The type of alloy, the type of metal that's being used inside your contacts is not something that we would choose in the field. However, the manufacturer will build that relay depending on what your requirements are, and they'll make sure that you have the right material for your contacts to best suit your purpose. You've reached the end of 204 Part 5, so make sure you review these three types of metals and you know what their pros and cons are, and then you can continue on to Part 6.